the resources, the expertise, and the persistence to compromise any organization at any time. Are you prepared? Join us as we ask and answer 4 key questions crucial to your malware protection strategy. How did it get here? Where did it go? What is it doing? And how do we stop it? We're going to cover advanced malware protection for endpoints, the Cisco web security appliance, and intrusion prevention. It's the SourceFire Advantage right now on TechWise TV.
So this is the FireAmp console then, right?
That's right, yeah. This is a web-based management console for controlling the FireAmp solution, and that's the connectors that run on endpoints. So we support Mac OS X, most flavors of Windows, Android 2.2 and above, and VM virtual clients as well.
Okay. Let's talk a little bit about a client, because a lot of times we get a little nervous about that type of stuff. So let's get down to the real meat and taters here. What's the size of that client?
It's a thin client, and everything about this is designed with performance in mind, because the people that invented this technology actually came from the old antivirus model of a heavy, thick client.
Like
I know, right?
Oh.
Where you put something on the machine, you're downloading DAT files, and running scans, it's bricking a machine, users are trying to disable it. So everything about that model, we're trying to have a new paradigm when we're building this functionality. It's a very thin client, it's a 20 megabyte application. It's sending just that SHA-256 of a file up and checking the disposition, waiting for something to execute or activate or load itself into memory. Generate the SHA-256, send it up to the collective security cloud for analysis, and wait for the response.
So 2 things. What kind of CPU load am I putting on here doing the computation and stuff, of course? And then what type of data pool am I sending across my network here? What relationally, what am I talking about?
So it's incredibly small amounts of both. Or the performance impact is something that no user is going to notice, right? You're not going to see the client do a system scan and everything get locked up, right? This is just a very simple generation of a SHA-256. That's a functionality built in most operating systems.
Oh, yeah,
anyway.
sure.
In fact, you can deploy this to be either active or passive, so we can actually hold the file's execution and wait for that, but it's a 1/5 of a second round trip to get the response back.
Okay.
Right? And then things can proceed.
That's where you really have some pretty nice advantages in, right? You have actually this client there that now gives you the ability for not just one-way communication, but two-way too, because you can actually reach down and grab instances on that machine, right? Grab files and yank them out of memory, that type of stuff?
In fact, we can. The agent itself, the connector, the client, whatever you want to refer to it as, does have the capability to pull files out of memory if we change our disposition. Right? So remember, I said we're tracking at where all these files are. So if we ever decide that a file has gone from a neutral disposition to a bad disposition because we've gained more information about it, well, we know everywhere it is, and we'll tell all of those agents to pull that file out of memory and put it into quarantine. And that's where you start to get into some of this automated remediation, which we call retrospective detection. Because it's not just about detecting it at the very first instance. It's about knowing where it's at and being able to respond even after that fact.
Show me.
So, well, here we've actually got the console up. And what we're trying to do with this technology, and what I think is pertinent to administrators, is to answer 4 main questions. They want to see, number 1, how did this get on my network?
Right.
Where else did it go?
Oh, yeah.
Right. What is it actually doing?
Uh-huh.
And then how do I stop it? That's the ultimate question.
Yeah, that's pretty well
If you can answer those 4 questions, you're gonna be okay in this battle against malware.
The forensic 4.
Yeah. So here at the top left, you can see the indicators of compromise, and we've identified a few different aspects of this particular machine that make it look pretty fishy to us. So we can look into this and answer the first question of how did this happen. So here we have device trajectory, and what you can see at the top left is all of the different executables and files that have run on this system. Now, as I scroll backwards to the left, I'm actually looking back in time and seeing what has happened out here. So as we scroll back over here to the left just a little bit, I can see that this particular user opened up chrome.exe, went out to a website that looks like ownme.com. I don't recommend going to ownme.com, by the way. But shortly thereafter, you see a bunch of interesting behavior because Java is actually dropping a file, and you see multiple attempts of executing a file here. Why would Java be doing something like that? That's suspicious behavior.
Yeah.
Right? So then after a little while, all of these indicators mean something different. Here the file was put on the system, then it was moved, then it actually executed. And then you see the piece of malware itself, which we know is malware because it's color-coded as red, has actually dropped another file itself. So we're showing you exactly the chain of events that occurred that identify how this machine got infected. So that's how did it happen, right? We know what's happened here. The next thing I'm going to want to do is identify the fact that this is a machine that's infected, but it's probably not alone, right? Where are the rest of these ants? If you see an ant walking across your countertop, you don't think he's by himself. You know, he's got other friends that are out there. So where are the rest of the ants? So we can go into the search function here, and I can pull up one of the files that we wanted to look at. And here on file trajectory, this will pivot our view. Now, we were looking at one machine and everything that happened on that one machine. So I'm going to change my view to what's happening across all of the machines. Where else has this file been? Right. So if I scroll down here, here are all the other ants. These are all the other machines that have executed this particular file. Right?
And the times.
Absolutely, in order. So the very first user here at the top is audit group development-56. If I scroll down just a little bit, that is your first instance of this file executing. That's your patient 0. Yeah.
Son of a gun.
So now you know exactly what happened, how it got on the network, where else has it been. The next question you want to know is, what is it actually doing? Right? So we can go straight from here and launch into a file analysis. And this will show us a lot of the information that we're getting from our cloud-based sandbox, where we can identify that a particular file is doing some really bad things. It's trying to modify the Windows firewall. That's bad.
Yeah.
We can see some information about the PE header, the portable executable header. We can see some information about the printer style functions, right? And incident response teams love the amount of detail here because they can understand exactly what this thing is trying to do.
Yeah.
You can also use this information to write custom signatures against families of malware, right? Then we can also even see some networking information. Now, if you see this particular IP address and you deem this to be malware, what do you think that IP address is?
It's probably command and control.
Exactly. Do you want that on your network?
No.
So one of the things we can do is share this information with our network-based solutions.
Access controllers.
Right? And add it to the blacklist and IP blacklist through our security intelligence feeds for the IPS, for the WSA, ESA, and things like that. So this is how we're sharing information from multiple components of the system. They're all sharing that information through the cloud-based architecture. So now we've seen what it's doing. Even if SourceFire hasn't deemed this to be malware, you have the control to be able to identify its behavior, where did it come from, what is it doing, and see this kind of information. And even if we've missed it or we haven't declared it as malicious, but you don't want it on your network, watch how difficult it is to add this to a blacklist here. I highlight the SHA-256. I put this in my simple custom detection list. Click add with that check mark. Now this file is blacklisted. This SHA-256, that was it. This SHA-256 will never be allowed to execute on another endpoint again, full stop.
And that goes out and propagates out immediately to all your clients.
Immediately, because now the cloud has notified all of the other endpoint agents that are out there that this file is bad, so it will go back and pull all those other ants out of memory and quarantine this particular file. Right? And that's the beauty of the visibility that we provide by tracking where we're seeing all these executables.
That's pretty cool.
Yeah. So you don't have to go back and try to fix every individual machine and have people send in their laptops and try to format hard drives because that's horrible for productivity.
Or send out the email. If you notice the following thing, do the next steps. Like, oh my
exactly.
God.
No, it's already taken care of. And not just for this one machine, but for all the machines that have ever executed this file.
Also, the nice thing about being in the cloud and stuff, too, is that it's not a land-based solution. If I've got remote branches out there or something, we can cover them as well.
It's another huge advantage. A lot of people are approaching the malware problem from a network-based solution, trying to put network sandboxes in. But you have to consider, what about my remote users?
Because if I'm going to hack into your corporate network, there's no friggin' way I'm taking on a headquarters firewall.
Yeah.
I'm going to a remote site and piggybacking in that direction.
Well, some malware is even network aware, so it looks around and identifies the network, and it says, if this is a big network, it's probably got security, I'm going to go to sleep.
Yeah.
And wait till the user gets on a home network, right? So even when these endpoints are not under the umbrella of protection of the network-based devices, we're able to have solutions that are able to identify and remediate threats.